Okay, welcome back. In this video, we're going to prove that 4 to the power n plus 15n minus 1 is congruent to 0 modulo 9. Here, what we're going to do is we're going to use the principle of mathematical induction to prove this result. Okay, so that's the good way to start. Okay, but first we see if this one is true for some small values of n. So when here in this case, when n is 1, so we have 4 to the power 1 plus 15 times 1 minus 1, that's 4 plus 14, that's 18, that's 9 times 2. Okay, and as we know that in this case, that means this number divides this one. Yes, because it does divide 18. Okay. For n equals 2, we have 4 squared plus 5 times 2 minus 1. That's 16 plus 30 minus 1. That's 16 plus 29. That's 45. And 45 can be written as 9 times 5. And therefore 9 divides this number. So a quick idea in the principle of mathematical induction, when we prove this result, we have to make this one appear, this 9 here. We have to make it appear in this sum here. Okay, and that's what this one means exactly. This means that we need to prove that 9 divides 4 to the power n plus 15 times n minus 1. Here n is bigger than 1. Okay, and to do that, the easiest way is, as I said, is using the principle of mathematical induction. So let's call the statement here P of n is 9 divides 4 to the power n plus 15n minus 1 with n greater or equal than 1. Okay, so in the principle of mathematical induction, we have to check the following. We first make sure that P of 1 is true. Okay, and after that, we're gonna assume that P of n is true for some n. So this is the induction hypothesis. Okay, and we assume this is true, and after that, we're gonna prove that P of n plus 1 is true. Okay, so once we do these steps, we conclude. Okay, so we need to have a conclusion about this one here, and this is most of the time when we say that this is true for all n's bigger than 1. Okay, so let's work it out. You can stop here and do all the steps by yourself, or you can continue the video if you have seen this before. The first thing is that P of 1 is true. Yes, because when n is 1, this statement is that 9 divides this number, as we have seen. So when n is 1, we have seen that this sum is 18, and 18 divides 9. And 9 divides 18, sorry. So 9 divides 18 in this case, because 9 divides 9 over, 9 can be written as 9 times 2, or 18 is 9 times 2, and we have this 9 here. Okay, and now we assume that P of n is true. That means we assume our induction hypothesis. That means we have that 4 to the power n plus 15n minus 1 is true. That means 9 divides this one here. So this is the induction hypothesis. But we're going to write it in a different manner. This 9 divides 4 to the power n plus 15 minus 1 means what? It means that 4 to the power n plus 15n minus 1 can be written as 9 times k, with k some integer. Okay? But here, since this one is positive, so this k is in n. Okay? So here we can write this one. This is the induction hypothesis. So we can write this one as I said, in this form. Okay, so this is 4 to the power n plus 15n minus 1 is 9 times k. So most of the time, when we try to prove or to do next step, which is we have to prove that p of n plus 1 is true. That means what? That means we have to prove that 9 divides 4 to the power n plus 1 plus 15 times n plus 1 minus 1. So when we do this one here, we have to link it to this induction hypothesis. So we have to use this one here in somehow. Okay, so we want to prove this result here. That means what? That means we need to write, if we can write 4 to the power n plus 1 plus 15 times n plus 1 minus 1 as some 9 times some a, that means we have proved the p n plus 1, which is 9 divides this number. Okay, so when we get here, so let's prove that this is true. Okay, so what we need now is to use the induction hypothesis. Okay, so we have this result here. This is true because we assumed that by the induction hypothesis. Okay, so here now we want to prove that this one is this sum here on the left, or Pn plus 1 is equal to 9a. Okay, and to do that, we have, so we want to prove that 4n plus 1 plus 15n plus 1 minus 1 is equal to some 9 times some number. So this is the goal that we want to prove. Okay, so to do that, we're going to start from here. So 4 to n plus 1 plus 15 times n plus 1 minus 1. So here I can use this induction hypothesis, but here I have 4n plus 1. Okay, so I can use only 4 to the power n. If I can, let's use that. So 4 to the power n is what? It's 9k minus 15n plus 1. So we're going to use this one in here. Okay, so to do that, to use 4 to the power n, we're going to use the algebra to write 4 to n plus 1 as 4 times 4 to the power n. So this is 4 times 4 to the power n plus 15 n plus 1 minus 1. Remember, the aim is to write this one as 9 times some number. So 4, now I'm going to use 4 to the power n. This is coming from the induction hypothesis. So it's 9k minus 15n plus 1 plus 15n plus 1 minus 1. Okay, so let me see if I can simplify this result. So here I have 4 times 9k. I can write it as 4k minus 4. So this is 15. So this is 15. 4 times 15n minus 4 plus 15n plus 15 minus 1. Okay, let's do some algebra. So it's 4k. So here I have too many terms that I need to simplify. Okay, so the first thing is that I have minus 4. Okay, plus 15 minus 1. So that means that's 10. Okay, so here I can do, or let me just simplify this one to make it easier. So a good idea is just to multiply. So 4 times 50 is 60, 60n, yes, plus 15n. Okay, and after that plus 4, so minus 4, so plus 10. So this is plus 10, in fact. Okay, so you can see that I can write this one as 9 times 4k. So here I can minus 45 and plus 10. Okay, so now what I need is, this 45, I can write it as 9. But the issue is, So I have a plus here. So 9k plus 1. So it's plus 1. So plus 1, I have the plus 4 here. I have this plus 4. So this is the mistake that I made. So this is plus 4. So it's minus 4. This is plus 4 here. So plus 4 plus 15 minus 1. That means 18 here. So this is the error. There is an error. It's 18 here. If you can see that, I made a mistake. This is an error. So now I can write 9 here. 9, 4k minus, this is 45 is what? 5. 5n plus what? Plus 2. Because 18 is 9 times 2. Note that I made a small mistake here when doing the algebra. Okay, so this is minus 15 and plus 1, not minus 1. I did minus 1. That's why I had minus 4. So it should be plus 4. Okay, so this is a small mistake here. So now we can have what? Now we can call this number here, this whole number, I can call it a. So I have 9 times a. And therefore, 4n plus 1 plus 15, 4n plus 1 plus 15, n plus 1 minus 1 is 9a. What does it mean? That means 9 divides 4 to the power n plus 1 plus 15 n plus 1 minus 1. And that means what? That means p n plus 1 is true. Okay? So therefore, I can conclude now. So in using the principle of mathematical induction, I have proved that this statement is true when n is 1. It's true if I assume that Pn is true and I proved Pn plus 1 is true. Therefore, I can conclude that this statement is true for all n's bigger than 1. Okay? And that's what I needed to prove. Okay? So this is all I need to do. Okay? Check small values and see if P of 1 is true, assume that Pn is true, and prove that Pn plus 1 is true. There was a mistake here that I had noticed. So this is algebra, just algebra, the addition, but I did catch that, and I factor out by 9, and I get the result that I need. So that's all we can do now. So if you see any errors or mistakes, please let me know. Thank you.